Hello, everybody. Today we're going to talk about polygons. So the word polygon literally means many-sided figure. Poly means many. Okay, it is a closed figure in a plane formed by connecting line segments only at their endpoints. Each segment is called a side, and each endpoint where the two sides meet is called a vertex. You need to know all those terms. Okay, so here we have some things that are polygons. These are all polygons. Okay. We have some things that are not polygons. So let's look at those and figure out why they're not polygons. So this one is a collection of segments, but they do not meet at the endpoints. So this is not a polygon. Same thing here with this. Okay, this almost looks like a triangle. Okay, but it doesn't meet at the endpoints. So again, not a polygon. This has one curved side. Okay, so the edges are not line segments, so it's not a polygon. This is not an open figure, or this is an open figure because it's got this gap in it. It's not closed, so it's not a polygon. And this, you could think of this as two polygons, except that they are connected here at this common point right here. So it doesn't meet at its endpoints. It crosses over in the middle of the segment, so that's not a polygon either. Okay. So polygons are classified by the number of sides, and I would expect you to know all of these names. So a three-sided figure is a triangle, a four-sided figure is a quadrilateral, which literally means four sides, three angles. Pentagon, okay, pent means five, that's five-sided figure. Hexagon is six-sided figure. Now seven-sided, you can do Greek or Latin. Heptagon or septagon, both of those are known by that. 8 is octagon, 9 is nonagon, D is decagon, 11 is an undecagon, 12 is a dodecagon, and after that we pretty much just say an n-gon. So if it's got 15 sides, it's a 15-gon. Now I think this is interesting. You know, you got sept, oct, no, and dec. Okay, so September is the seventh month, right? Except that it's not. It's the ninth month, but it used to be the seventh month until Julius Caesar came along and decided that his birthday needed its own month, and so he created the month of July. And his successor, Augustus Caesar, decided that his birthday needed to have its own month, so he created August. Okay. And that pushed September back from the seventh month of the year to the ninth month of the year. October is no longer the 8th month, it's now the 10th month. November is now the 11th month, and December is now the 12th month. Okay. Now, we got a polygon here. This is a pentagon. It has five sides. We need to name it. Now, we can name this in multiple ways. Generally, what you do in this case is you'd start with the first letter in the alphabet, and you can pick any corner you want to start, and you can go clockwise or you can go counterclockwise. So most of the time this would be called A, B, C, D, E. Okay, I could also call this A, E, D, C, B. And I could pick a different corner. I could start with D. I could call this D, E, A, B, C if I wanted to. What I can't do is I can't call it D, A, B, E, C. You don't skip around. Okay? You pick a corner, any corner you want, and you go one direction around the polygon. Okay? All right. A diagonal is a segment that connects two non-adjacent, so adjacent means next to, so two vertices that are not next to each other of a polygon. So a diagonal here, this would be a diagonal, BE. It's a segment, so we put a little segment name above it. Okay. AC, that's another one. Okay, this actually has 5. BD would be another one. EC would be another one. And DA be the last one. Okay. AB is not a diagonal of this figure. It is a side. Okay. A segment connecting two adjacent vertices of a polygon is called a side of the polygon. So we talked about that. This has 5 sides. It's got AB, BC, CD, DE, and EA. A polygon is called convex. Too much stuff on here. A polygon is called convex if no diagonal goes outside the polygon. Or you can say the polygon has no dents in it. Okay, so a triangle is always convex. Okay, but this figure here is not convex. It is non-convex or concave because it has a dent in it. If I were to draw this diagonal from here to here, it would go outside the polygon. Okay, so it is not convex, it is concave. All right, if a polygon is not convex, it's concave. So here we go. We've got some convex polygons, and we've got some concave polygons. So this has 5 dents in it. This has 2. This has 4. Okay, so it's concave. Two polygons are congruent polygons if and only if they are exactly the same size and shape. Okay, so what does if and only if mean? That's kind of an important term that you're going to run into a lot. If and only if means, this phrase actually means 2 things. It means if 2 polygons are congruent, then they are exactly the same size and shape. But it also means if they are exactly the same size and shape, then they are congruent polygons. Okay, so it means both ways. Now that doesn't always work with everything. Okay, so sometimes you see if and only if written like this. Other times you see it written like this. With the symbol, it's a double arrowed deal like that. Okay. Okay, an if and only if statement means that 2 statements are true, the original statement and its converse. Okay, so again, if the polygons are congruent, then all corresponding sides and angles are congruent. And if all corresponding sides and angles are congruent, then the polygons are congruent. Okay. So here I've got 2 figures. I've got A, B, C, D. I've got W, X, Y, Z. And I have something called a congruent statement. This is a congruent statement. It says that A, B, C, D is congruent to W, X, Y, Z. Now, this symbol, you see this symbol? It means congruent to. Okay? It means 2 things. It means, this part means that it's equal, which means that all the sides are equal, all the corresponding sides are equal. So AB corresponds to WX, those are equal. BC corresponds to XY, those are equal. YZ is equal to CD, and ZW is equal to DA. Okay, and all the angles are congruent. So A and W are congruent, B and X are congruent, C and Y are congruent, D and Z are congruent. Now, when you write a congruent statement, it is important that you put things in the right order. Everything has to correspond. So if I write A, B, C, D first for this one, then I have to write W, X, Y, Z for this one. Not because it's necessarily alphabetical order, but A and W go together. B and X go together. C and Y go together. D and Z go together. So when I look at this statement, if I just had this statement and nothing else, I could tell a lot of things about these. I know that angle A is equal to angle W. I know that angle B is equal to angle X, and so on. I know that segment BC is equal in length to segment XY, and so on. Okay? So you match up the corresponding parts when you write the congruent statement. Okay, an equilateral polygon is a polygon where all the sides are equal in length. Okay, equilateral means equal sides. The most common ones, you've got a nice triangle here, equilateral triangle, a square, pentagon, equilateral pentagon, okay, equilateral hexagon. An equiangular polygon is a polygon where all the angles are equal in measure. Okay, so in this, all these would be 60 degrees. All these would be 90 degrees. All these would be 108 degrees. All these would be 120 degrees. Okay? Equiangular, equal angles. A regular, this is an important term right here, a regular, whoops, that's not what I want. A regular polygon is both equiangular and equilateral. Okay? It's equilateral and equiangular at the same time. So these right here are all regular polygons. Could I have a polygon that's, let's say, equilateral and not equiangular? Yes, I could. In fact, if I had something like a rhombus, it's equilateral because all the sides are equal, but it is not equiangular. These two angles are equal and these two angles are equal, but they're not all equal, so it is not regular. Another one would be a rectangle. This is equiangular. Okay. Whoops, that's not what I want. It's equiangular because all these are 90 degrees. Okay, but it is not equilateral because the sides are not equal. Okay, so we would say this is equilateral, but not equiangular. This is equiangular, but not equilateral. Okay. All right, so there's our assignment for today. You got a couple pages there. So I will see you guys in class. Have a great day.